welcome back, everyone. I hope you've had a good lunch. So it's my pleasure to introduce the next session, which is the one on system design. So how do we get from secure cryptographic primitives into systems that users can utilize and still provide them with guarantees of security and privacy? The answer is the art and science of cryptographic system design. So today we're going to have two case studies, and the first one is going to be presented by Pulumi and Anna. They're senior crypto analysts at Lista Authority, and they're going to present us with their case study on consulting freely to provide them with unlinkable identifiers for phone numbers while still providing the basic functionality for a phone service provider. And the stage is yours.
Yes, so good afternoon, everybody. Yes, we want to tell you about a recent project that we're consulting on, and we're like talking about it, like we're discussing a design and some engineering things. And just to give you some feedback just to give you some background on what we do. So we work for a company that is consulting in cryptography in general. So we do security audits, cryptography audits, but we also do cryptography design work. So it's very hands-on, and we help other companies have better cryptography. So that's the idea, just for you to have like a background. And we had recently a project where our client Freely was saying, I'll paraphrase it, we need unlinkable, linkable identifiers. And the thing is, unlinkable, if you, like in this specific audience, like we know unlinkability, right? Like we've heard about it either from blind signatures, or the EID, for example, as well. Identifiers, we also know. Like, we know session identifiers, we know all sorts of like other identifiers. So that should be like fine. But the problem was in this specific case that we still needed some sort of linkability in the back. And why was that? That was because the company we were like consulting for, and the client that we had is called Freely, and Freely is a phone service provider. So everything, SIM cards, numbers, the whole stack, and they have the one unusual product commitment. They want their own customers to be as private as possible from Freely itself, not just from outside attackers, but from the company. So the threat model actually includes the company. So they need to be able to issue you a SIM, to provision it, to bill you, to run the service. And at the same time, they want to avoid building a database that says this account belongs to this phone number, and this belongs to this calling pattern. So this is the idea. And in general, like continuity and accountability in this specific setting across all these interactions, they still want to have it, and yeah, they want to recognize a returning customer, but prevent the company's own systems to track. So very different to the usual phone service provider. So this is the background of the situation, and we'll go a little bit deeper into that. So what this meant in practice when you consult with companies like that. So as you can see, when we discussed with Freely, we would get product language like the examples on the left. Things like don't let anyone track users, and support law enforcement, still let us detect repeats, avoid centralized identifiers, but let's have some sort of anonymous mapping, something like a blinded associative store, things like that. And all of these things sound more or less reasonable in this product setting, but if you actually want to think about what specific primitives you want to use, these are not really helpful. So obviously we need to understand don't track users, don't let anyone track users. So how exactly should users be unlinkable? For whom? Like we understood from the company, but how is the company structured? Like how is the server architecture? Like how exactly is the design of the system? Over what time window? What time window are we talking about here? What do we have to include in this like specific design? For example, for the repeat situation, is that just equality testing? Do we just want to check like one customer like against another ID, or is it just frequencies of like buckets, let's say? So each of these things means something else in general. So just to give you like an idea, there was a lot of like transactions, what freely called transactions, or phone service activities that we had to map, and we had to understand how they interact between like in the system. So I just like picked something out from the report. Is just a simple transactions that we had to understand here. So in general, when we were thinking about this design, there is a lot of like cryptographic primitives that we could use in this specific setting, right? This engagement in general, just so you understand the timeline in the industry, was just 2 weeks. I'll let it pause here because I think a lot of like things that we normally see in research papers, it's like months or years of work. This specific work, we did discuss this, like we did talk to a client before to like specify the engagement, but the whole like design phase of this engagement was 2 weeks. So we had to first, like the slide that I showed you before, we had to, in this 2 weeks, understand exactly the architecture, their objectives, and then also in this 2 weeks, do a very, very, very broad literature analysis to then explain to the client what of these things would make sense in their in their setting and what not. So yes, all these techniques exist, but not necessarily, they were not necessarily all applicable. So yeah, so we know like a lot of primitives, a lot more than here. It's just an example. There's a lot more that we could use to model this, but we had to understand from talking to the client in this 2 weeks what the main security guarantees were. And yeah, the unlinkability I mentioned of some user ID to phone ID. But then also we need to have abuse detection. That means that if on the phone ID side of the thing, of the phone number, is being abused by the party, this needs to be detected and it needs to be shut down, and the account also needs to be shut down. So this direction we also need kind of from the phone number to the user ID. Another thing that we also needed is a chargeback possibility. That means when you buy actually like a phone number or like a SIM, you would pay with your credit card potentially. And your credit card, there's a possibility for you to get a chargeback from that, and then the service needs to stop. So this direction of like having the payment being cancelled and your phone number also being cancelled, this direction is also something that we needed to model. Yeah, so this would be something that we discussed. We also, besides these like, let's say security guarantees or like more functionality things for this model, for this design, we also had constraints by the client. So the thing is that the client told us that they would prefer minimal engineering difficulty. This means that they just had a very, very, very short timeline of a couple of months to do the engineering work. So options need to be deployable and not necessarily interesting from a mathematical perspective, which I think in this audience is sometimes more motivation. So that meant we need mature implementations, we need well-reviewed libraries, we need integration paths that didn't require heavy lifting from Freely's engineering team and also our engineers who assisted. We also needed for this design, we also needed something explainable to non-cryptography stakeholders. This also means that the solution that we need to find is something that we can explain, because otherwise nobody's going to fund it as well. And we needed some sort of flexibility in case the requirements are going to change. So in our in explaining to the client what would match, we identified that some sort of anonymous credential token or blind signature solution would be something that we would propose. This was just the initial design. Poulami is going to talk a little bit more about the cryptography behind that. It's a work in progress as well. It's an iterative process, but this was just the initial design phase. We were also thinking about a matchmaking encryption, which would give us a lot of expressiveness. We could have policies which different parties could have to encrypt and decrypt specific things and specific information, but this requires functional encryption, so it's kind of complicated. And other techniques are also a little bit too involved. So this is just the idea. And just to give like the specific audience also like some more background things. So in practice, we have like the cryptographic design, right? So we have to like combine some primitives together to have like a design. But in general, if you then actually want to implement it or deploy it, there's things that you also need to discuss, which are attacks on timing. You need like some sort of like batching, for example. How are keys handled, rate limits on this information, metadata that's being passed, and monitoring that you want to implement. So this was also something that we had to include in our design work, which is not necessarily like a cryptographic design, but it's more like cryptographic engineering on top that we also consulted the client on. Yeah, and one aspect of the architecture that we just wanted to focus is that we actually proposed to the client to have an architecture of 3 different systems. So we would have a user server, which would handle all account-related things and know the customer, create an account, do all the payment things, update contact details and stuff like that. And a phone service, which would handle all the SIM and phone number related things. And these 2 services should not talk, but they should talk, the whole, like all the transaction being passed, should be passed through a mixing server, which will help with all these like timing attacks by batching and re-randomizing requests, and should be operated ideally under a different trust domain. So this is just a general architecture idea, and Pulmi is now going to talk a little bit more about the cryptographic design that we were thinking about.
Yeah, thank you, Anna. So let's look now what kind of solutions we came up with, which is, as Anna said, still a work in progress. So yeah, so the 2 main security privacy properties that I'm going to talk about here. So the first of all is, of course, user authentication, because the user service is going to receive requests from the user and then going to process those transactions before sending it to the phone service. So before processing each transaction, it has first to authenticate whether the request is coming from a valid user or not. So we, of course, need to do the user authentication there. And since we were interested in getting a solution from anonymous credential area, so we chose to use Privacy Pass here. So this gives us to achieve user authentication through issuance and redemption of anonymous tokens. So we also found a nice Privacy Pass library from Cloudflare, which we could integrate and adapt quite easily into our protocol implementation. So that worked fine. But in this talk, I'm going to mostly focus on the next privacy property of user ID to phone ID unlinkability, which as we saw from the security privacy requirements of Freely, that many of those requirements were reducing down to this particular privacy property. So the first solution that we had to deliver was in a very strict timeline, as Anna mentioned, because they wanted to deploy something quite fast. So our first solution is quite simple. It's actually a non-cryptographic solution, I would say, where we have a mix server which has a mapping of the user ID and the phone ID. So what we are going to do is that whenever the user service provider is going to talk to the phone service provider, it is going to do via the mix service, where each transaction which is containing the user ID is going to just look up for the phone ID in the mapping of the mix service, going to replace with the phone ID, and then transfer that modified transaction to the phone service. And for the transaction back from phone service to the user service, we are going to do the reverse mapping. So, so the mix service is also doing reordering of the transactions and batching transactions per transaction type, so that there's at least some kind of anonymity set created, like when a batch of transactions is being sent from the mixing service to the phone service, for example, then within the anonymity set, it is not easy to decode the mapping back. But of course, this solution relies on the trust assumption that the mix service doesn't leak this mapping either to either of those service providers or to the internet. And then, yeah, so it's basically trusted. The mixed service is basically trusted here. So this combination of privacy pass protocol along with the mixed service implementation is what we went for the initial deployment. So they are currently freely is live since last year, and they chose to go with this solution. But of course, we were not happy with this solution because this is a non-cryptographic solution with trust assumption. So our next iteration was to try to come up with a solution that can remove this trust. Yeah, so a little bit of what we were thinking here while designing the solution was that it will be nice to get the trust distributed. So, and also a practical solution, of course, and then we were thinking in the direction of solutions from threshold cryptography. So the first thing that came to my mind was, why not try threshold encryption decryption? So maybe we can do some kind of threshold decryption of the mapping at a time, and then the mapping is revealed. But there the problem is that then the servers that participate in the threshold decryption actually learn the user ID, phone ID mapping in clear, and this is not what we wanted. So we ideally want a solution where none of the entities will learn the user ID or phone ID mapping in clear while computing the evaluation for them. So then we kind of shifted and came up with like a working solution, which is a combination of two main primitives, threshold oblivious PRFs combined with hybrid encryption. So yeah, I will go through the solution a bit to understand how we are using threshold OPRF here. So first of all, when we have the user transaction containing the user ID, the first step for the user service is to get output from the threshold OPRF service. So the user server will talk to the threshold OPRF service. So first it needs to prepare the input. So we are using the user ID concatenated with per user ID secret seed, and we are computing hash of that and using it as an input to the threshold OPRF. Then we get the threshold OPRF output and store hash of that value as the first part of the mapping. Now, this is the first time the mapping needs to be created, because the user ID, this mapping is created for the first time. We need to make an entry in the mapping table. So the first time we need to create the phone ID randomly at the phone service and then encrypt it, and then this mapping is stored at the mixed service. And so what the user service will do is that first derive the threshold OPRF output, obtain the hash of that output, and then the mapping is created. And for the next times when the same user ID is called the next time in transaction, then it is going to do a lookup in this mapping table with the hashed OPRF output and get the encrypted phone ID. So replace the user ID with the encrypted phone ID and this send the modified transaction to the phone service. Now the phone service can decrypt, in this encryption, the phone service has the decryption key. So it is going to decrypt the phone ID, then it is going to perform the transaction as was specified. And at a later point of time, it has to send back a response to the user service. So it is going to then query the same table. Depending on the encrypted phone ID, it is going to retrieve back the hashed OPRF output and going to send it to the user service. Now, user service has to maintain an internal mapping table of IDs to the hashed OPRF output so that it can trace back to the user ID that for which the value came from, and can inform the user that this kind of operation was completed. So this is kind of the whole flow of one transaction flow from the user service to the phone service to the user service back. Yeah, so why we think this works on a high level is that we are getting most of the properties that we want from the threshold OPRF. So the threshold property of the OPRF gives us distributed trust. So we are planning to have a set of servers which is going to be hosted both by list authority and freely, so that we can make sure that when the threshold OPRF will be computed, that both of the entities are servers are participating in this evaluation. And then the pseudo-randomness of the threshold OPRF output gives us the unpredictability that we need from the output, and the obliviousness ensures that the input as well as the output is not learned by each of the servers which participate in this evaluation. So there are some limitations which I still don't like about this solution, which is like, first of all, we are using this hash of the user ID and concatenated with the secret seed. This is necessary because at the moment we have the assumption that the threshold OPRF service is accessible to like other entities too. So if some, like any entity, including the adversary, is going to query the threshold OPRF with the same user ID. So user ID is, usually threshold OPRF is used in the context of password-based protocols where we know that the password has low entropy, but user ID doesn't work there because it's a public value, and we cannot assume that it will be secret, because it will, although we don't reveal user ID here, it will be revealed in other interactions. So that's why we have this hash of the user ID to create like an unpredictable input that we are feeding, so that we can ensure that the threshold OPRF that the user service is running, the same inputs are not being used by when it is accessed. However, we want to rethink this part, and we also want to consider whether we can do some password-based authentication between the user service and the threshold OPRF service, and get rid and make this step cleaner. Another thing is that there's another internal mapping that we need right now at the user service with the user ID and the hashed OPRF output, because otherwise we don't have any way to trace back. When we have to process the transactions, the responses back from the phone service to the user service, we still have to trace back which user ID it came from. And so that's why, I mean, this is an extra mapping, and this kind of is not good when the user service is corrupted, because we have this storage there. However, we, at the moment, we are, if each of these servers gets corrupted, we are still able to satisfy user ID, phone ID unlinkability, even when the mixed service and the phone service collides. That also doesn't reveal enough information for them to retrieve the linkability. So we have some guarantees here, but we hope and we think this solution can be improved. Yeah, and yeah, there are some further improvements that, this is the last slide, so yeah, I want to mention that there are some further improvements that we would like to get here. So as I mentioned, if the user service and the phone service, these two collides, then they have enough, all the information to break down linkability. So that kind of corruption is not handled in the current solution. So that will be nice if it's possible to get. And then the next thing is to support encrypted payload, end-to-end encrypted payload, because currently in the deployed solution we have payload information containing users, some users' data which is getting revealed to the mixed service. So this will be good to integrate. This is not like a challenging task, but we would like to add. I mean, we don't need to search for a unknown primitive, at least for this step. So we hope that this can be done. And yeah, post-quantum security is, of course, important. However, yeah, we are going to see whether this will be much challenging to consider. Yeah, and the threshold OPRF solution that construction that we considered in our design is for this reference. However, we have to see if we change it to the password-based authentication, it might also change into a partial OPRF, or partial oblivious PRF from a oblivious one. So yeah, So yeah, that's it from me. Thank you for listening. I'm happy to take questions.
Thank you very much, Pulumi. Anna, are there any questions from the audience?
I have some questions about your threat modeling. So you're assuming that the user server and the phone server do not collude,
Yes.
right? How does this work in practice? Because in practice, Freely is one company and they're probably operating both of these servers.
No,
Or
the
how
user
does this
service
work?
is a different company. So
Okay,
that's,
so
we have that.
You assume that the user service is outsourced to another.
Yeah,
company.
it was also helped us to build a threat model because it's literally a separate company. So that's why they are only dealing with the phone-related transactions, and all the user-related data is being handled by the other company. So that's why these are completely two different entities where we can separate the threat model a bit.
Okay, thank you. Just one quick follow-up. Can you briefly repeat for me why we now need the mixing service? Because
Why we don't need?
why we need the mixing service if we assume that these servers do not collude? Couldn't they just use some pseudonym in between them?
I can jump in on that. So the thing is that they are not colluding, that we assume, but there is things like timing attacks and like things that where we want to batch things, for example, where we need, it's more of a relay situation where the mixing service though also does not learn any user ID and any phone ID. I think that was one of the first solution that Pulumi was talking about, is we do have a privacy pass based token situation there where the user service is sending in like a token, and then that specific thing is sent like batched and re-randomized batched and then sent over to the phone service. So this is the need for it. It's more like a batching timing situation, and also a relay through this token service, basically. Yeah, it's more an engineering situation.
Also a bit separation of roles, kind of.
Okay, let's thank the speakers again.